Hey, Sean.
Hey, how's it going? Can you hear me?
Going great. We have people filing in from our last event. Looks like we have just got a bump. So I'm here to introduce Sean Hillen, CIO at Radix. Am I saying that right?
Radix.
Radix, excuse me. At Radix. And today we're going to talk about unleashing autonomy, how adaptive planning and dynamic tool use paved the way for truly autonomous intelligent agents. I'm so excited to hear more. And with that, I'll get off the stage and hand it over to you.
Cool. Thanks for having me. And I'm going to attempt to share my screen here. So just, all right. Should see my slide deck here. So a little bit about myself. So I'm currently the Chief Information Officer at Radix, which is a real estate intelligence analytics platform. Previous to that, very recently, I just moved over here, but previous to that, I was at Cohere for a few years. Cohere is a foundational large language model provider. If you haven't heard of them, similar to OpenAI and Anthropic, we built large foundational models. The founder was one of the original authors of the attention is all you need paper. Sorry, slipped my mind. So now I'm actually working on the application side, building on top of models like Cohere. So I ran the solution architecture org at Cohere. So I think just a little bit of context, what I'm trying to bring to this conversation is we were taking Cohere's models and we were bringing them into different domains, into different enterprises, and helping them architect solutions around these models. So I've seen a lot of what's working, what's not working, and I'd like to always try to cut through, all the demos you see, all the hype, like what's really going on currently, what's still with the direction we're headed, and what still needs to be accomplished or achieved. I'm kind of assuming 100 level, and I know people are all different levels of AI knowledge in this room. But I'm going to start from move through pretty fast the basics of this, and then kind of slow down a little bit when we get into the meat of the presentation. But I want to build a framework for thinking about like the 4 discrete buckets. There's different ways to look at this, but I look at it for the sake of this presentation in 4 different types of applications or companies that are building in this space. You have your infrastructure layer, which is the nuts and bolts, the compute, the storage. These are your hyperscalers. Yes, these companies do have their own models they're trying to build, but for the sake of this is your infrastructure layer that this foundational models run on. And so the foundational models are your OpenAI, your Anthropics, Cohere. And then on top of that, we have this middle layer. And your middle layer is any of the tooling that exists around it, everything from databases or orchestration tools or whatnot. These are how you take these models and build on top of them the tools that you're using and the way you orchestrate the workflows and those type of things. And then the top is the application layer. And I'm really looking at this as like, this is where I believe the next wave of innovation is coming from. And hence why I'm at Radix now is that there's companies that are taking this very powerful general intelligence in these foundational layers and bring it into their domain or in their enterprise in spaces where they are subject matter experts. They have the proprietary data, they have the proprietary processes that either need to be encoded in the model or need to be built around the model. And so that's really the 4 discrete buckets that I'm going to be talking about when I refer to these companies. So at its very core, these foundational large language models at the beginning, they're just sequence to sequence models. So you've put the language models, you put text in, you get text out. And basically they're just completion models. So the prompt, you pass them some text and it's the sky is, and then it completes it by either blue, black, red, whatever. There's some completion. But under the hood, these are non-deterministic models. So essentially there's some distribution of answers. We know 1 out of or 9,995 out of 10,000 times the sky is going to be blue. There's some sort of distribution that says that. So almost all the time we're going to get blue back. But there's sometimes we do get wonky answers out of these models, especially the ones that have not been fine-tuned or whatnot, because and so that's what we call hallucinations. And so you have the ability to change the distribution by passing some additional information to the model, like it is storming outside. And you can imagine if it's storming, it's less likely that it's blue. So there's some distribution under it. The majority of the time, you're going to get black back when you pass this additional information. This is important because when we start talking about augmenting these models, that's essentially what you're doing in an augmentation, is you're bringing in some sort of information from outside the model into the prompt. And this is very powerful in enterprises because enterprises, the majority of their value is locked up inside their data and in their processes. And so you have to get this information into the model for it to be valuable in the enterprises. So a real quick evolution of large language models. If we look down at the bottom here at this completion model, the foundational model is what I just talked about. When these first came on the market, very powerful, but because they do not interact, they kind of interact in a first person type way, like they're completing what you're saying. They weren't super useful to people at the domain level who weren't in these models every day. And so what we saw with the instruct style models is there's this level of tuning with feedback from humans on how to better follow human instructions. So you tell the model, tell me what color the sky is, and it says the sky is blue. And so this is just a level of tuning or a level of training on top of this core model. And then as we move up this stack, they become more impactful inside businesses because it becomes communicates more like a human. So then they're trained on multi-turn conversations. So this gave us the ability to have stuff like ChatGPT, where it can complete a conversation, use historical knowledge and those type of things in the conversation. And then kind of where we've been over the past year, roughly, is these retrieval augmented models. And retrieval augmented models are just models where you're bringing in you're retrieving from some set data source, a database, a CRM, your enterprise search, and you're augmenting this model with some additional information, so that bringing in the weather forecast from an API is going to change probably what color the sky is going to come back with just the model. And so this is kind of just a very general view of where we've moved through over the past 18 months to 2 years for most folks who've been following this. So I want to start to think about, like, what is an autonomous process? So I asked Cohere's latest R+ model, and it says an autonomous processes are self-governed. Autonomous processes are self-governed systems that can operate, make decisions, and perform tasks independently without external control. So I would agree with that, pretty accurate. But when we start thinking about autonomous processes, where do we want to start? And after running through so many cycles of solution architecture around companies that are trying to implement this, I can always say that where you want to start is currently with human-driven processes. Because what's powerful about these models, these generative AI models, is because they have the ability to accomplish outcomes based on non-deterministic thinking. So similar to what humans would call critical thinking. So we want to look and see how we can augment humans, or take a portion of things that humans are doing now and augment that with the speed and power of compute in these models. So I'm going to look at like a human-driven process, and then we'll work from there, but get an idea of what's involved in like a robust human-driven process. You start with some sort of desired outcome. So here we're in a product organization, and there's a chief product officer. Fairly normal request here. What are the most requested features from our customers? He's building out a product roadmap, or looking over the product roadmap. And there's some sort of interaction that goes on with maybe a data scientist, a subject matter expert. There's some people that have to understand the intent, like what is he looking for, what would actually be an artifact or an output that would answer his question. And maybe they come to the conclusion that if I bring you a chart of the top five, a chart of the top 5 features requested and the frequency that they are requested, that it'd be a good start. And so there's some sort of iterative conversation that goes on with the product officer and some sort of subject matter experts. Maybe those folks go to the team leaders. Team leaders have conversations with their teams. This happened all the time in the organizations I've been in when I was on the solution architecture team. Asking sales folks, they get a ton of touches with customers. They have access. The sales team may go into Salesforce, use Salesforce to kind of drill through some old notes, go through call transcripts, just really trying to figure out like how to best represent that voice of the customer. And this is a process that, these processes take days, because you have to have people go and do some research and that sort of thing. But this results in some, if you have good record keeping and you have good data sources, you can get some pretty robust feedback on that question. And then you may have like a follow-up. That's just a single question. So all that is just to answer that single question. And then you get back to the chief product officer and then he goes to the VP of revenue and says, out of these features that I was given, which one represents the largest revenue opportunity? So you can imagine this process happens again, involving different subject matter experts, different domain level experts, where they come back with some sort of answer for this chief product officer. And so when I think of that process, like what makes that process robust? From just the human-driven process, what makes it robust? Well, integrity. So you're using reliable, factual, and up-to-date data, whether it's in a database or it's coming from actual humans. It's interactive, and so the ability to, when he asks that question, you can ask clarifying questions to understand intent, objectives, those type of things. Introspective. You come back with, humans create some sort of artifact or output, and they have the ability to double check their work and look over and be like, this doesn't sound good. They can show it to somebody else. And so we have the ability to be introspective and revise what we've done to come up with the best product. Strategic, in order to accomplish these more complex tasks, you have a strategy, and then you've got some sort of tactics you're going to execute on, and that takes planning, that takes forecasting, kind of modeling what is the future going to look like, the ability for me to plan for things. The process needs to be dynamic. So throughout this entire process, you're learning facts, and as those facts change, you may be going to the next step might change. So you may be using a different tool or a different application or whatever. Collaborative. The ability, if we look back at this chart here, or this diagram, you've got so many different subject matter experts, just human level experience that is ingrained into this process. So right now with these retrieval augmented generations, we kind of solve this, not solve the problem. We have made this process more robust because we're getting this real-time factual data, the data with integrity. The product officer asks us who's our biggest customer, Walmart. They're like, okay, cool. But there's no feedback in this process. So this answer could actually be wrong. Maybe the product officer meant the largest by revenue, which he probably did. And so if it would initially been able to ask these clarifying questions and had that collaboration, you would have had that information and been able to generate an answer that actually answered his question. So that's that interactive piece. So before you go and you do these retrievals and perform these tasks, these robust, now autonomous systems we're talking about, they need the ability to ask clarifying questions of the person who is giving them the task or the desired outcome. And so in this situation, he says the largest customer by ARR on our platform, and that changes the answer. That ends up being Exxon, 2 million in ARR. So now he gets the correct answer after the interactive collaboration. The introspective piece. So being able to leverage these language models to not only generate the response, but also to reflect on their response. And so does this correctly answer the question, generate the right outcome? If it doesn't, we need to send it back through and give instructions on why it didn't. Like you don't have the right retrievals from the system. You could have never garbage in, garbage out. We need to actually go back and get a different type of retrieval to bring into the generation. Dynamic. So this is something that we're seeing the model providers that they've built into their models now, and you're really seeing that it's allowing people at this application layer to do some really cool stuff. And this is the ability to you place a query or you give the model an instruction, and it actually at runtime outputs what in most cases is a JSON API call to the tool that is best done for the job. And so it really picks what tool it's going to retrieve from at runtime, and maybe there's some set of tools that it needs to use, and it's actually choosing those as it goes. We'll talk a little bit about how it thinks about choosing what tools, but it now has the ability to choose the right tool for the job. And this is where you have this multi-agent interaction as well. So I'm going to dial down really quickly into like a specific example here of this. This is really starting to look like a more robust process that's not single-threaded, that actually is iterative. So here's our chief product officer again saying, show me a chart of the top 5 feature requests we heard from our customers in 2023. And the second piece is, are we addressing those features on the roadmap for 2024? And so like a robust autonomous system is going to need to create a plan. These models have been shown to do very well when they actually start off and think through the steps and the actions they need to take, and then executing on those actions. So we've created a plan here, the 5 steps. First, it's going to be retrieval step. We're going to go to Google Drive where we know our call transcripts are, retrieve the transcripts. Then we're going to pass it to the model, analyze them, the call transcripts for feature requests through the generative model. And then we're going to, step 3 is we're going to take the 5. In step 2, we're actually going to pass the top 5 feature requests or whatever he's asking for. And then step 3, we're going to generate, this model has generated at runtime, has decided at runtime it's going to generate Python code and then display a chart. That's the best way to show him that. And so it's going to actually pass, it's going to actually do an API call to the Python interpreter. You're going to have a chart there. It's going to go further and answer the second question, realize step 4, okay, we have the chart, we're going to put the chart up, but now we need some analysis around the product roadmap. Our product roadmap is in Jira. So we're going to have an API call that comes out of the model to Jira. The product mode roadmap gets queried and extracted from Jira and now passed back to the generative model. And the generative model is going to do some sort of analysis on it against the top 5 features to see how many we're addressing, and then answers the question. Right now, 2 out of 5 of the most popular features requested are on the roadmap for 2024. So this is a process that could take hours or days of researching this, and this is something that's happening in this process in seconds. So this is just one single workthrough. So you can imagine, like, this is an autonomous process, but you can imagine as there's thousands of these processes that exist in daily work. And the more of the decision making that goes from that can be offloaded onto the model, and that's what this dynamic tool request and selection allows the models to do, is allows it to make decisions based on real-time information as it comes in. So the second piece here is similar to what we were doing there, but in a similar type question. We're getting the top 5 features. We're asking back from the previous process, and the chief product officer is asking which one of these represents the largest revenue opportunity for our company and why. Well, we know like if you work in a large enterprise, that like a lot of this data is owned by whatever the domain is inside the organization or the business owners. And so that general agent may not have access to the CRM to answer the question, or may not have access to everything that a revenue officer would need to answer that question. And so this is where you have multiple agents. We have multiple subject matter experts in an organization, multiple domains. Like there's no reason why we wouldn't have multiple agents. And these agents can be, and they can be prompted models that have very specific prompts around them. They can be fine-tuned models, but these models represent more specialized versions of that base model. And here we actually have the general model through its plan decide that it needs to call on the revenue agent, which is the revenue model. And that revenue model is going to accomplish the feature that represents the largest revenue opportunity for the company. So it's going into Salesforce and it's going to extract data out of Salesforce. Pull some numbers around there. Maybe there's other places they get market intelligence, Salesforce market intelligence, those type places. It's going to do some sort of analysis. It's going to pass. It's going to take that data, decides the chart's the best way to represent it, call in the Python interpreter, and then also answer the question of why. Where are those numbers coming from? And so this can be a multi-turn conversation. It can go back and forth between the chief product officer and these agents. And this is when you truly start to be able to pull in the different domains in an enterprise to get to be able to augment these existing processes that could be laborious and time consuming now, and increase the pace of innovation by an order of magnitude. So I moved through that pretty fast because this clock's ticking right here. I don't know if this is the time I have left to ask questions or whatnot. So I will happy to double back on any of those slides.
Awesome, Sean. Thank you so much. What a cool presentation. I love the way, first of all, you made it visual for someone like me, I'll say, and made it and built it up and made it easy to follow. We've got some questions in the Q&A for you with our really 3 minutes left. The first one I'm seeing is, are there any open source frameworks for creating multi-agent workflows? Yeah, so that's actually a great question. Is like the tooling around these models is there's still not a clear like winner. You have like LangChain does some of this stuff, but then the model providers also have their some of this tooling built into their APIs. I will say Cohere, we released maybe a couple of weeks before I moved into my new role here. We had released a framework called Toolkit, which is really cool. What it's done is it's essentially if like you come from the GPT world, it'd be like taking all the wiring for ChatGPT and open sourcing it. They did that for their Coral product there, and it gives you the ability to stand something like this up very quickly and at the least POC. And I think that what Cohere's hoping is that like people take that open source framework and start to like put it in production. Really cool product. Awesome. So that one gets at Vivek's question. I'm going to we just have a second here, so I'm going to take a part of Nicholas's question. He is asking about issues with standardization. How do you think about sort of some of these workflows and insofar as customization versus standardization across different companies? Yeah, so I think this is where the applications get very interesting. It's like we need companies to build out applications. The models are not at a point now where they can just be standardized across domains. And we saw people try to do that for the past year and a half. We really need these application companies to come and build on top of these models. Sure. Or enterprises that are large enough, take a large, like a Salesforce or somebody, they're building on Einstein GPT, like companies like that are experts in their domain that can build out the around the models, or a company that services a specific domain that can give, like healthcare domain can give the data scientists in healthcare the right tools to build their own models. And so it's really a tooling problem right now. Mm-hmm. And it just depends on the industry. Got it. Makes perfect sense. Let's see. I guess I'm gonna wrap it here so we don't get randomly cut off. I'll give you 30 seconds. Do you have any closing thoughts here for the audience? Let's say the idea behind this is really thinking through the way that you wire these things together. A lot of it is still old school orchestration, and that's fine. These aren't just magic dust you sprinkle on it, and these models will get better at it. But you really want to think about like offloading as much of the decision making, the intelligent, critical thinking onto these models as the models get better. And like for instance, the tooling piece of being able to dynamically choose a tool. That's something that didn't exist a year ago, and now that exists, now you've offloaded the ability to choose tools as opposed to like hardwiring it in. So thinking of like, how do you make these scalable? How do you make them more as robust as a human process or as close to as possible? Okay, so with 5 seconds, thank you, Sean. I'm here to close this out, so there actually won't be a next section. And I hope to see everybody here tomorrow. So thanks again, Sean, and thanks everyone for joining. Thanks for having me. Bye. Yeah.